It's sharing right now. Okay. Hello, Professor. My name is Kong Lin, and I'm going to explain my code. The code is question number 7. It's on homework 2. So the question number 7 is asking to use a stack to solve a maze. So by that question, right now I have a 8 by 5 square maze. Then the black area is not accessible, so we can only access the white square. So I'm going to find a path in this white square area. So to do that, first of all, I have to tell the computer where to start and where to end. So where's the beginning, where's the goal? So that would be my given. And I will use the stack to store the data of my path, to store all of the point on my path into the stack. So the given is the recording. Okay, so the given is the start and go. So the position, the coordinate of the star is 5b in this of 8 by 5 square. So yeah, I know my star. So first of all, I will push the star into the stack because that's the first point of my path. So I push it into a stack. So right now I am standing at the start. So the problem is, where is the good square that I should move to the next? So I have to find a solution to tell the computer where should I go. So the solution that I find out is that I will going to check my current square for different direction. It's 4 different direction, which is south, which is north, south, east, and west. Then I will follow this order to check um, to check if the next square is good to go. So let us do the tracking. So first of all, I'm at the star square. Then I'm going to check my north square. It's a wall, so it's not accessible. So I will going to check my south. The south is white area, is white square, so that is good to go. And I'm not going, although my west square is also the white area that I can go, but because of the preference of my check-in, the order must be from, I must check from north to the west. So if I find out the south is good to go first, then I will choose south first. So since the south is good, I will mark the south square as a 1 to tell the computer that this is the visit square. And what is the benefit of visit of when I'm doing the marking on the visit square? I will explain that when we meet that situation. But right now we just remember that we have to mark the visit square or something. So for this, for now, I'm just mark as 1. And after I mark the square, I will push this coordinate into my stack because that's the second point of my path. So I will push 6b into my stack. Then I'm going to do checking again. The south is so good, so I will mark 1 and push the coordinate, that's 7b. Then I'm standing out here and I'm going to check the west seems good. So I'm going to go to west and mark 1 and push the coordinate 7C into it. Then I'm standing at 7C. I'm going to check north. It's a wall now. I'm going to check south. Good to go. And that is AC. AC. Push into stack. So right now I'm at AC. I'm going to check north. Now it's a visit. It's a visit square. Can we choose that? No. Why? Because that is the way we just came from. So this is not the nice square to choose, and that's the reason why we have to mark the square that we already visit, because we don't want to waste our time to visit the square that already been. So that's the reason why we have to mark something on the visit square. So we are right now at AC, then we check north, that's the visit square, no good. So we check south, that's a wall, no good. Check east, that's a wall too, no good. So we go to the west. So where's mark 1, that's AD. So right now we are at AD, then we're going to check north here. So here, then we push mark 1 and we push 7D into here. So right now we are standing at 7D. Then we're going to check the full direction. First of all, check north. It's a wall, no good. Then next, check south. It's visit square. That is also not the good choice. Then we check east. That's the visit square as well. Then we check west. The last we check west. Then we find out that there's no way to go to access. We are blocked. What can we do? So the best solution the best solution to deal with this situation is called backtracking. What is backtracking? So the backtracking is just we go back to the last step and choose the second best of choice. Remember, if we go back to the last step, that is AD. That is AD. That is AD. So when we were at AD, we got two choices. One is go to north, the other one is go to south. But why we go to north first? Because the north is our first preferences. So that's why we go to north. But right now, after we went to north, we found out that it's not a good choice. That's not a good path. That's the day end. So we have to do the backtracking. So what is the backtracking? The backtracking just delete what you have at that square. So we have to delete. So we have to delete the coordinate in the stack. And we go back to AD. Then we go back to AD. Then we already go to north already. So this time we will go choose south, because south is good to go. So we go here. Go here. Here is good to go. So go here. That's the same thing. We mark the 9D. We mark 9D as a visit square. Then we push 9D into our stack. Then keep going. Then we south is still good, so we go what's that? That's 10D marked. Then right now we are at 10D. Then we going to do a check. North, no. South, no. East, east is our goal. 10C. So how can I tell the computer that our goal is go? So right now I also have to write a code that to tell computer if the stack is going, the path is going to, it's going up to it's going if my path, if the path, the point is the same as my goal, then that is the end of the path. Then my computer find the path from the start to the goal. So this is my basic idea um, of finding the path in the maze. So right now we are going to check the code. So here's my code. So I have the header file. I built a class called coordinate. And first of all, I have the overload constructor that takes 2 points, that takes the coordinate of the row and column. So whenever there's a coordinate is built, it will just contain a coordinate inside that takes the data of a row and data of column. Then I need to have this get the row data of in the maze function. This get function that will just return the position of the maze. I'm sorry. Let me try to go back. And I also need to have this get maze column that will return the position of the position of column of maze, and that's just private variables. So right now we are going to look at the function. It's called find path. So the find path, we're going to take five parameters in this function. So the first parameter is maze. That take the chart type because there's a lot of different character in this maze. So yeah, I'm going to do the 12 by 12 maze. Then I have to tell us as what we say in the beginning. We have to have the given of the start point and the given of the goal point. So that's the given, and that's the given. So first of all, we need to have a stack that store my coordinate. So this is the way how I declared the stack with the coordinate type. So each stack that will just store my coordinate of the of every point. So I code that stack stored coordinate. So next one is just given start point with the coordinate type. So you will just have like literary coordinate. So next one is just pushing into my stack because we already explained that before. It is the first point of my my path. So I would use this while loop. When my stack is empty, that means I'm sorry. So when my stack is empty. That means there's nothing in my coordinate. Then I won't do the searching. We will talk this later, but basically this is just the backtracking. This is the backtracking step, but I want to explain that later after I introduce this check function. So right now we already have the start point, and then going to this while loop, this while loop. There's something inside, it's not empty, so I'm going to do this while loop. I'm going to do this while loop. So first of all, we will just check whether the top list value of stack is a go. So if you remember that we have the first step of the stack is just a stack with a start point, and the start point is not a go at all. So we just keep checking. So when this hits, when the top of this, then the top of the stack, variable stack hits the goal, then that means I find the path. So when top of this is a top, when I go through all of this, when top of this coordinate is a goal, it's the same as a goal. That means this is my path. So this is this code, and so if my top list value is not a go, then I'm going to do the checking. So I'm going to do the checking. The procedure of checking we already explained in the by this Excel file. So we are going to so we will just keep standing at the current position and check the 4 different direction. Then if it's not a 0, the 0 is the 0 means wall here. And is not the star sign. The star sign means visit square here. So if it's not a wall and it's not the visit square, that means that is good to go. Then I will push that good square into my stack, because that is my my point of one of my point of my on my path. Now push that coordinator into the stack, then mark that square as a visit square. Right. So, but what if there's a situation when we the point didn't pass all of this check. If it didn't pass all of this check, it would just end this else statement, then go back to here. Then go and to end this statement, then go back to check the while loop. The while will still have the value. Remember, when we are up to this, I think it's here. When we are up to here, we have to do the backtracking. Then at this point, we still have the value in the stack. So that means this while is still working. So we were up to this backtracking step. So what does the backtrack step do is just find the previous topest value and just remove it. Just remove it from the stack. That's just like what we did before. We just remove it from the stack, but it's not remove the mark, but remove the value of from the stack, because that is the wrong path. We cannot store that is stored in the stack. Remove it, then just keep going to check the next good string, the next good square. the reason why we cannot remove it, the visit bug, is because we will still go back. We will still pass this for check. So I have to avoid the path, choose the north again. So I have to keep the visit square over there. And then it will not choose the north at next time. It will just go back to check south. So after all of this, it will just find out the paths. So that's my header file. So let's look at the main function. So the main function include my header file. Then this is my maze 12 by 12. Then first of all, I will show you the quiz. I will show you the original maze. Then I will give the start point. The start point will start from 1 to 1, then going to 10 10. Then you'll visit. You will just use the find path to see if there's a path in this maze. So let's run this code. So this is my maze on 12 by 12. You can and go. That means my code find out there's a path from my given start point, which here S, and to my given goal is here 10 10, position 10 10. So all of the start sign is the path that the computer tried to go, and you can see the code even went to the wrong way, but since there's a backtracking, so they just keep going back and to this point and to find out, and depends, and according to our preference of the checking function, they will just keep moving to find the path. After all of these attempts, the code finally reached to the goal. Of course, you can see there's some white square that didn't go. It's because the preference. So that is all for my question 7. Thank you.